So actually this chapter is about the special relativity. So we'll talk about the simultaneity, time dilation. So two fundamental characteristics in described in the special relativity, and the relativity of the length. And next we will talk about the Lorentz transformation, the relativity of the velocity, and the Doppler's effect for light. And finally we'll talk about the momentum and energy. So for the relativity, special relativity, there are two postulates. 有两个假设。So the first one is the relativity postulate. Relativity postulate 就是相对性原理啦。那 the laws of physics are the same for observer in all the inertial reference frame. Inertial reference frame. No one frame is preferred over another. Inertia means moving in a constant velocity. 就是那个惯性坐标系。惯性坐标系。So inertial reference frame, which means that the reference frame itself does not accelerate. So actually, you don't see much things implied by that. It only tells that the law of physics are the same. So it's quite abstract. And we jump to another one. The second one is called the speed of light postulate. 就是光速的假设。So it is quite conflict with our common sense. The speed of light in vacuum has the same value, c, in all direction and in all inertial reference frame. This is very strange. 用中文来说的话，就是说，那个光速啊，在真空当中啊，任何方向、任何的惯性坐标系去看的话，它都是同一个速度。就是说，如果你镜子看着那个光过来的话，它是那个c 2.998乘以10的8次方。你如果用半倍光速朝着那个光移动的话，你看到那个光速也是2.998乘以10的8次方 meter per second。你用1/2倍光速啊，朝着那个光离开的话，你看到那个光还是2.998乘以10的8次方。这跟我们小学学的那个概念就已经不一样了。小学学的时候，我们就觉得说，比如说我用3个 meter per second 朝着你过来，你就看到我3个 meter per second 朝着你过来。那如果我用3个 meter per second 朝着你，你用1个 meter per second 朝着我，那我就会看到你朝着我是4个 meter per second 嘛，对不对？但事实上啊，这里的话是光速的话，你怎么动，你都看得到那个光速是 c， 这个就一开始就违反我们的常识。So we can also phrase this postulate to say that there is in nature an ultimate speed c, the same in all direction and in all inertial reference frame. Light happen to travel at this ultimate speed, 就终极的速度啊。那 however, no entity that carry energy information can exceed its limit. 那他也说，就是没有任何的东西可以超过这个速度啊，However, moreover, no particle that has mass can actually reach speed c, no matter how much or for how long that particle is accelerated. So both postulates have been exhausted tests, and no exception have ever been found. 他说这个那么违反 违反直觉的事情，那事实上我们没有找到一个反例去推翻它，没有找到反例去推翻它，因为我们活在这个世界当中，我们速度很慢的话，我们按照我们以前学的那些法则去计算的话，其实没有什么问题。但是当那个速度开始很快接近光速的时候，事情就变得不一样了。事情就变得不一样。他们就是要考虑到一些比如说我要加速一个粒子到比如说1/10倍光速、半倍光速或者是多少的时候，他们就不能按照我们那种小学的那种常识去计算，它就会出问题。那就是大量的实验结果就告诉我们说，这个光速应该是一个常数。那包括一个历史，就是当时人们就觉得这个世界需要有一种叫做以太的东西嘛，我之前有稍微提过，就是有一种叫做以太的一种介质去传导这个光嘛，传导这个 EM wave 嘛。那当时他们就设计一些实验去找这个以太应该要存在的，但最后就变成说后面就会提到，就会说就发现根本就最后就是证明这个世界根本就没有以太。那现在我们如果接有线网络叫那个以太网络，就是那个名字就是从它而来。So this graph shows that so this is the speed of light, 2.998 times 10 to 8 meter per second. So actually, in classical mechanics, we know that the kinetic energy should be 1/2 mv square, right? 1/2 mv square. I suppose you should have learned it in high school, right? So which means that suppose we have more energy, the speed should be higher. So at that time, the scientists try to put more and more energy on the particle, but it finds that even you make the energy to be very, very high, it cannot still exceed the ultimate speed, the speed of light, because for this one, as long as k is large enough, it should be some value for k that v could be larger than the speed of light, which means that v equals 2k over m, take the square root. So m maybe it is an electron, which is 9.11 times 10 to minus 31 kilogram. So suppose this k is large enough, then we should be able to be larger than c. But actually, they fail to do so. It finds that even you increase the kinetic energy by a lot, then this one cannot exceed the speed of light. So its speed can never equal or exceed the ultimate limit speed of c. So later in this chapter, you know that suppose the rest energy, the rest mass for the electron, maybe an electron for the rest mass is 9.11 times 10 to minus 31 kilogram. So you know that as long as the speed of this electron increase to maybe half of the speed of light, it mass become larger. So it's just like that. If the speed is very close to the speed of light, its mass will become infinitely large. So it will fail to increase its speed to be equal to the speed of light. So in chapter 35.5, actually we skip this chapter, but actually there is a experiment they set up to find the ether. So this is called the Michelson's Infernometer， 就是叫做 Michelson's 干涉仪，这个叫做干涉仪。So an interferometer is a device that can be used to measure the length or change in length with great accuracy by means of inference fringe。所以其实你们在高中应该也学过什么单狭缝干涉或者是什么双狭缝干涉那些。那就是如果两个光啊，它们就是什么有双效干涉或者是什么干涉，那它就会光暗相间的去它就是跟那个 phase 有关了。它们同向的话，它们就会叠加啊；如果是反向的话，它们就会消掉。所以中间的话，它就会介于中间，所以就会有光暗这样的情况发生。那 so this interferometer also try to which means it can use this inference to measure the length of the two paths for the two paths. So in Michelson's interferometer, a light wave is split into two beams. Then we combine after traveling along different paths. So this is the source. It generates the light, and then this light will split into two. So one path going this way, and the other path going this way. So it will go to this mirror, and then go back, and then this path going to M2 and then go back. So maybe D1 and D2. So maybe D1 and D2. So D1 and D2 maybe have a different length. And then they come back, and then finally part of it here will go back this way, and then part of it will go through, and then similarly for this path go to this way, some of it will go through, and then some of it will go to this way. So actually the wave some of it going to 2D, some of it going to 2D2, and some of part of it going to 2D2, part of it going to 2D1, and then this path is the same. So actually they will have some inference here, and then by measuring this pattern here, we can know that the difference for D1 and D2. And suppose this interferometer is on the Earth, which means that you know that the Earth should be rotating, which means moving in one direction maybe. So actually, suppose part of the light is going in maybe X direction, part of it is going in Y direction. And you can imagine maybe the Earth is moving in one of the direction. So if the velocity of the Earth can add to the speed of the light, then you should be able to measure this speed difference. 就是说，如果那个地球如果在转动的话，它如果在这个方向，它如果在 x 方向去动的话，它应该会影响到这个 x 方向的那个光速，它应该会那样。但实际上我们发现的事情是， 它并不会影响那个光速。所以这个是其中一个实验去验证说，这个光速啊，在任何方向、任何惯性坐标系上面都是同一个光速。So this is using this Michelson Infernometer. So Michelson-Morley experiment is the original objective of this experiment is to prove the existence of ether, but failed. So the conclusion of this experiment is that the speed of light is a constant for different inertial reference frame. So so you can check it here. So it is the most famous failed experiment. So the next we talk about the simultaneity and time dilation. So an event is something that happened, and every event can be assigned 3 space coordinate and 1 time coordinate. So maybe this one XYZ, this one is the time XYZ and the time. So 4-dimensional space time. So among many possible events, the turning on and off a tiny light bulb, and the second, the collision of 2 particles, and the third, the sweeping of the hand of a clock plus a marker on the rib of the clock. So if 2 observers are in relative motion, they will not in general agree as whether 2 events are simultaneous. If one observer finds them to be simultaneous, the other general will not. So this is something strange. So because so suppose this the upper one is moving to the right side by a velocity of v. So maybe so this upper one is moving in the x direction by v. So suppose maybe there exists some clock which knows that this one and this one occurs simultaneously, and actually maybe this one is called B prime, this one is called R prime, which is on this train, and B and R is on this train which is stopped, maybe stopped to some reference frame. So, and actually this explosion occurs here, and then this length and this length is actually the same. So for Sam, it's very trivial. Sam will think that because this explosion will need some time to transmit to here, and this explosion also needs some time to transmit to here, and the speed of this information to transmit is the speed of light because it's explosion. So you can see that side there may be some explosion, and then after some time, which is the length of this maybe x, this is also x, so x over the c will be the time it takes to transmit this information b to Sam, and also r to the Sam is also x over c. So the time here is x over c. This is also x over c. So suppose if they can be regarded as occur simultaneously, so it takes x over c to transmit this one. And actually this one is moving. So as long as this this signal is transmitting, this train is already moving. Maybe this speed is quite high, maybe a tenth or a third to the speed of light. But actually, as long as it's moving, so Sally is on this train or rocket. So Sally may consider that the red event occurs first. The red event occurs first, and the blue event occurred later. So Sally receives the wave from the event red first, and next Sam will detect both events simultaneously. So wave from the two events reach Sam simultaneously, but Sally detects the event blue later. So Sally will think the red event occurred first, but Sam will consider blue and red event occurs simultaneously. So this is something special here. So if the relative speed of the observer is very much less than the speed of light, then measured departure from the simultaneous are so small that they are not noticeable. So if this speed is quite low, then actually they cannot sense this time difference. But such is the case for all our experiments of daily life, and this is why relativity of the simultaneity is unfamiliar. 所以你可以想象，就是比如说你飞机啊，就是那个超音速啊，音速的话是多少？音速的话是大概300多个 meter per second， 我忘记是340还是340吧。340，这是3乘以10的2次方。那光速的话是3乘以10的8次方，它差了6个零，差了6个零。所以这个是光速，这个是音速。那战斗机可能到几倍音速，那已经需要很长时间的训练才能够坐上去，不然普通人是承受不了的。So the spaceship of Sally and Sam and the occurrence of the event from Sam's view, spaceship was right. 对，它其实 so actually just said what I just mentioned, detect the wave from data. So the time interval between two events depends on how far apart they occurred in both space and time. This is their spatial and temporal separation are entangled 的意思是那个 entangle 是那个纠缠 entangle， 就是你有听过，如果那个量子纠缠就是 entanglement， 就是 quantum entanglement。所以你要说那个事件啊，是不是同步的话，它跟它们的速度啊，还有那个位置是有关系的。So this one, event one is for this B transmit a speed of light to the mirror. So as long as it is stopped, so it's just go to the mirror and go back. And for this one, suppose this B is moving in a horizontal speed of v, moving from here to here. So it takes delta t to move from here to here, and it transmits the light from here to there and go back to here. So the length it takes is not d, is L, and this is d. So actually for this one, as long as it is stopped, so this d over the delta t0, maybe it takes the time to be delta t0, should be the speed of light. This should be the speed of light. But here, the light travel through 2L, and it takes the time to be delta t rather than delta t 0. So in this case, the speed of light should be 2L over delta t. Should be 2L over delta t. They should be the same, which is the postulate for the special relativity. Yes, so for this case, delta t0 is called a proper time. It's called a proper time. Proper time 就是标准的时间哦。那 so observer in frame moving relative to the frame, such as observer on the track watching， 就是跟之前那个火车那个例子是类似的。那 effects. So actually, for this one, so actually for this one, for this so actually for this one, the time, the speed of the time, the time for this one and this one is not the same. It's not the same. And it is called time dilation. 时间膨胀了。So observer in frame moving relative to the frame, such as observer on the track watching steady, we always measure a larger value, delta t. So delta t should be larger because it moves for a longer distance. So this one is 2d over delta t0 should be the speed of light. But for this one, it is something like 2L over delta t to be the speed of light. Because L is larger than d, which means that delta t should also be larger than delta t0 to make the right side both equals to c, to the speed of light. So this is called a time dilation. And next time, tomorrow I will move on.